Okay, I'm troubleshooting my Homelite 360 chainsaw, and the problem is it doesn't start, and I believe it's got a no spark issue. So something in the ignition system. As you can see, I've started to tear it apart, but I thought I would pause here in order to make a video, because I've learned a lot this week by reading and watching other videos on the internet this week. So I thought this might be a good time to just show people what's involved in the ignition system and what could possibly go wrong. So there are four main components to the ignition system, and like I said, I've already taken this apart earlier. But you got the ignition module here, okay, and then that through this tab, this wire that is connected to this tab goes over to this cradle. I'm not sure what to call it other than it makes contact with the transformer. And the fourth component, I guess don't ignore the switch, because sometimes apparently the switch can cause a non-starting issue. The switch in the run position is ungrounded, and then in the stop position it just basically grounds out the ignition module. This is the wire that connects to the run switch. So anyway, again, it's the ignition module, this cradle, the transformer, and the switch. Okay, so a lot of people jump to the conclusion that it's the transformer that's bad because, because it's easy to get on and off, and one of the things I found from reading, is that you should be able to check this. Now, I don't know if this is a 100% method, but you should be able to check it with a meter. Okay, it should be close to 0 ohms between these two tabs. So in my case, it's half an ohm. Okay, and then from each of these tabs to the center point of where the spark plug contacts, it should be about roughly 2.5 k ohms. So in other words, roughly 2,500 ohms. So there I've got 2330 ohms, and over here I've got there you go. I've got about 2,400 ohms, or in other words, 2.4 kilo ohms from the right side contact to the center point where the spark plug. So I believe this transformer to be good. At least I'm going to assume that for now. Okay, so what else can go bad? Well, this one of the other obviously important and more complicated parts of this is what they call the ignition module. But I found out a way to test that, and that is, you buy one of these. I bought off the internet a $12 circuit tester. It doesn't have to be that particular brand, of course. It's just a circuit tester that tests DC voltage. It'll light up when it's got anywhere from 8 to 24 volts, I believe. So what you do is, while this is all assembled, of course, and including the pull rope, what you do is you use this tester to test between these two contacts. Now, in this case, I actually used a nail, okay, and what you should find is that if you use this tester between these two contacts, that it should flash as you're pulling, and it may require two people, or maybe easier with two people, but if your test light flashes, because this is a low voltage, a relatively low volt, 12 volt, I guess, it should flash as you pull that. And so that, if it flashes, then that's saying that the ignition module is doing its job by sending a signal. Oh, by the way, very important. When you do that test, it has to be in the run position. So the switch has to be in the run position. And of course, if that test is successful, then it tells you that the switch is working as well as the ignition module. Now, of course, the switch, I mean, especially if we've got it exposed here, you can test that using your meter, and it should, like I said, when it's this is the line coming from the ignition module. When the switch is off, that line should be ground. This goes to ground. Basically, grounds out the ignition module when the switch is off, as all kill switches do. And when the switch is on, it's open. So my switch is good. All right. So we've used our meter to verify that the transformer is good. We've used the meter to verify that the switch is good. And earlier I used this test light to verify that the ignition module appears to be good. I was actually getting an intermittent lighting of this, and so it still doesn't start, even though I thought I had verified everything's good here. It still doesn't start. So what I'm doing now, I had again read on the internet that sometimes it could be a grounding issue with this side of this cradle. Okay, so let me explain what's going on here. This wire comes from the ignition module, right? And it goes directly to the, if you're looking at it from this side, it goes to the right side tab, okay? It goes to the right side tab. That tab should be isolated from ground. You'll notice that there's nothing there's this Bakelite plastic that it's connected to, so it's isolated from ground. On the other, and this side, on the other hand, which is of course the left side here, needs to be grounded, and it's very important that it be grounded. Well, one of the things I read was that a problem could be that with the grounding of this side, even though all the other components appear to be good, if this is not well grounded, then it could cause a problem. So one suggestion that I read was actually add a ground wire. So that's what I'm doing now. I'm actually going to add this ground wire that I made or found with other parts that I have. And what I'm gonna do is I'm gonna snake it through here, and I'm gonna connect it to this that bolt, that screw right there. And that way, when I put this all back together, I will definitely know that this is grounded, because when you look at it, I mean, this thing is relying on it's relying on this tab making contact with this painted surface here, which I can easily see where that could be a problem. Not to mention that this is then screwed through painted surfaces, screwed to the rest of the unit. So I'm going to try that, and I will let you know how I make out. Okay, after adding that ground wire and reassembling the saw, I thought it would be interesting to show you how this this automotive test light works. Again, I got this off the internet for about 12 bucks. It's got an LED light in the middle, which will light up when it detects voltage. So, as I said earlier, the best test, or the way to use this, is to probe between the right side contact where the transformer hit contacts and the left side. You know, so what you want to do is probe between there and there. Now obviously this alligator clip is so big I really can't probe this left side contact. So earlier what I did was I decided to use a nail to probe the left side contact, and then use this to probe the right side, and then have a second person help with pulling to see if I get a light here. After thinking about it, I thought, well, wait a minute, the left side is ground. You know, we talked about that earlier. That's where I added the ground wire. So I thought, well, gee, I should be able to just connect this directly to some point that's ground. And this is a convenient spot here to connect this alligator clip. And I'm gonna show you how this test light works. I'm gonna probe the right side with the test light. Hopefully you can see this LED light. Remember the kill switch has to be in the run position. And as I pull this, we'll see if the LED light lights. There you see it. So hopefully you could see that. And after doing this, I realized that this might be a good way of telling whether you have a good ground. I mean, as I said earlier, I added a ground wire, but what we've done here is basically bypassed that left contact point. Okay. So if you were to do this test, let's say exactly the way I just did it, and you get a flashing light, and then you probe directly to the left contact. Let's, you know, like with my nail. Okay, if I probe that left contact to the right contact and I don't get a indication of a spark or indication of a light there, then that would make it really suspicious that perhaps you have a grounding problem on that left-hand contact, because when you bypass it, it flashes and then when you go directly to the two contacts, it doesn't flash. So that could be a way of troubleshooting a ground issue with that left contact. So that's it for now. I'm going to go out and see if it works. Okay, there's one additional point that I'd like to make that I realized when I was putting this cover back on, the cover that has the cradle and the contacts to the transformer and the kill switch. This cover attaches to the unit with about 6 different screws. There's one underneath this cover here. There's one screw here, and then when you go over to this side, this mounting bolt here screws the cover on. This screw here, and then there's one underneath here, right there, that screws it on. And there's supposed to be 2 additional screws. One, and I think hopefully you can see this at the top here. The top of the cover has one screw there, one screw there on the other side. Now, when I had this saw totally apart about 2 or 3 years ago, I intentionally did not put those 2 screws back in because I wanted this cover to be easy to take on and off if I had to, you know, for troubleshooting purposes, in order to be able to get to that cradle unit. Okay, and I'm wondering now whether the lack of those 2 screws has influenced or impacted the grounding issue. In other words, maybe I made the grounding issue worse because I did not put these 2 screws back in. Those 2 screws go to just a simple little right angle steel bracket, but that steel bracket, it bolts directly to the aluminum cylinder head. So it's possible that I I created this problem by not putting those 2 screws in. Anyway, again, the advantage of not putting the screws in is that it makes the cover relatively easy to take on and off if you need to. But of course, now that I've added the grounding wire, I've solved the grounding issue. But I just wanted to add that it's possible that the lack of those 2 screws possibly contributed to this problem. Thanks. Okay, so this is the end of the day. Same day that I added that ground wire to the Homelite 360 chainsaw. This thing worked really well today.